It is remarkable to realize that the UML has been in existence for some 20 years. What a different time the world was back then. Here we saw just the beginnings of the internet. A new class of languages was emerging, the object-oriented languages, Simula, C++, Smalltalk, and the like. And we saw a tremendous evolution in hardware as well. These are the things that were very much in the world in the time, and as a result, it created an immensely vibrant time in software engineering. This is the time when we were moving away from classic algorithmic languages to these new object-oriented languages and moving to an entirely new class of applications as well, ones that were by their very nature distributed and also very, very large. In a way, this created a perfect storm for us. There was amazing innovation in the software engineering space. Work going on in abstract data types, people exploring different ways to try to build systems, but we also saw collaboration. I just happened to be at the right place at the right time working with the tools company Rational, obviously very in the middle of all this and very interested in not just building tools to help do so, but to help many customers around the world struggle and try to use these new things very, very well. I was not alone. Jim Rumbaugh, Ivar Jakobsen, Pete Code, Stephen Meller, Sally Schleer, literally hundreds, if not thousands, of people were engaged in this grand journey, and I was very proud to be a part of them. And indeed, I must offer great credit to all of these other colleagues who collaborated around that time, because were it not for that immense collaboration, and the Uppsala conferences in particular helped us out in that regard, we wouldn't be where we were. And so it came to be. Rational at its time had our method, Jim had his method, Ivar had his. And so, being wise business people, we realized at Rational there's fragmentation in the marketplace. Makes sense for us to bring this together. So we hired Jim. And the two of us set off and spent many, many hours in conference rooms figuring out how to bolt our two methods together. Why did we do so? Purely pragmatic reasons. There were enough similarities, it made sense to simplify and codify the commonality and grow upon it. About that same time, we were doing considerable work with Ericsson, where, of course, Ivar Jakobsen was doing some amazing work, and we realized, wow, there's a piece of it that fits as well here, and so we bought his company. And so thus the three amigos were born. In fact, I even have some t-shirts to that effect. It was hard work because we were all three very passionate, sometimes stubborn people, but I'm very proud of what we created. In the end, we created the 1.0 standard, of which I'm very, very proud. There are some great things in it. There are some things that I think we probably would have loved to have done better, but in the software sense, was good enough. And not just good enough, it was actually great enough. One of the things I remember in our rollout party for this, and it utterly surprised me. Here we were on some forum, I think it was at Uppsala, and Jim comes up and hands me a gift. It was a really cute gift. It was the book Aristophanes by Aristophanes called The Clouds, and then he broke into song, singing the wonderful song Both Sides Now, and we loved it. And Jim, I hope you did not pursue a career of singing because wouldn't have been a good thing, but thank you for doing what you did. That's when I gave out the Three Amigo shirts at the time. What have we done? Well, we created both a notation and the beginnings of a methodology, and I'm very proud that we codified it. It's just not our work alone. The three of us were the catalyst, but there are many others around us who made it so. At that time, I was ready to go on to do something else. So Jim proceeded with his work on being our representative to the OMG, Ivar especially continuing on the process side of things. I went in the direction of trying to apply these ideas to building systems of scale, worrying about issues of software architecture. So Jim, I believe, retired around this time. Around a little bit later time, we were acquired by IBM in 2003, and then I began to transition into the world of AI, working first with the Watson project and now on a thing called embodied cognition. As I look back, again, I'm incredibly proud by what we did. And as I look at the kinds of systems in which the UML was applied, it was truly the vast spectrum of things across the board. If you fly today, you probably are walking through or working through an air traffic control system that to some degree still has ADA in it that was probably designed using the UML. A number of defense systems that protect us use the UML. A variety of other transportation systems, financial systems, and even medical systems. In fact, one personal story to offer to you, every male in my family died of an aneurysm. And so when my nephew died of an aneurysm as well, I went in to get a CT scan. And I remember being in the CT machine and looking up at it and said, that looks very familiar. Why is that name familiar? And then I realized that I was inside a machine that was built by a particular company. And I knew that the people who wrote the software, and I knew that they used the UML. So immediately I was relieved. So I was pretty excited. So we can be proud of the UML. It's done some amazing things for us. Has everybody in the world used the UML? No, but it's also the case. Modeling is still an issue of getting traction, although many of us in the software engineering space know modeling to be so important. Then along came Agile. In many ways, what we did with the RUP and the UML itself helped lay the seeds for that. Our ideas of continuous integration and a rhythm of releases were very much in the elements of what we see in Agile today. We certainly produced the UML, the OMG standard. The work we did manifested itself in an IEEE standard on architecture. But I think most importantly, I'm proud of the fact that we helped people think in a particular way, think in an object-oriented way, and that's pretty exciting. So I'm very excited for what we've done. We're not done yet, however, and so although this work has been made manifest, there's a sea change forthcoming in the world of software engineering, and this is going to impact all the agilists in the world as well. And this is namely the introduction of components that are taught and that learn, and therefore we're forming systems that bring together symbolic and connectionist models of computation. So whereas the UML in its time frame was an especially vibrant time, we're not done. We're back in that time frame again where the same kind of innovation, the same kind of ideas need to be expressed. And the people who are out here listening, you're the ones who are going to do it. So go forth, have fun, create some wonderful things that make a difference. I know I had the opportunity to do so, and you do as well. Thank you so much.